everyone, welcome back to Code Rebel. I hope you are doing well, fantastic. Today we are diving into an exciting problem of LeetCode daily challenges, squares of a sorted array. It's a good one if you love and solving challenges and sharpening and algorithmic skills. You are in a right place. So our problem statement is a squares matrices. We are diving into a coding problem that's not all the tests of your algorithmic skills, but also offer an efficient solution to our common challenges. This is our problem statement given an integer array num sorted in non-decreasing order. We have to return here an array of the square of each number is sorted in non-decreasing order. So this is example number one, and this example number two. Input nums -4, -1, 0, 3, and 10. And this is an input arrays, and our output is 0, 1, 9, 16, and 100. Explaining after the squaring, the arrays become we have to squares of these numbers, and after the sorting, it's become our new output here. So let's see our approaches. Let's take our intuition behind it. So our intuition. The intuition of behind approaches is since input the nums of the array nums is 4 -4 -1 0 3 10. These are the inputs. Array is not already a sorted squaring in the elements. We will be result in a decreasing order of a sequence by comparing the square of an element's algorithm. That fact, the largest value will be an extremes of the arrays. And so our approaches. Let's see approach. First, we use here two pointer approach. Two pointer approach we have used. The idea is to have two pointer, one starting one starting from left left end of the array, left end of the array. Another we have starting for the array on other starting in right. First we have moved for left, and another we have to starting the two pointer approach is used for right side. So ARR right, ARR right, ARR left. These two pointer move towards each other, comparing the squares of the elements at their positions. The largest square values is at the end of our results array, and the corresponding pointers is moving to be inward. The continuous until both pointers meet at this corresponding pointers meet at the center. Let's take an example where here nums -4, -1, 0, 3, and 10. We for our approach is first one square the element, square the elements, square the elements, assisting 1, 0, 9, and 100. And second, these are our the square array. square array. And here use a two-pointer approach. Use two-pointer approach. Two-pointer approach. Here we have left 0 and right index 4. And let's say here we have to here compare these elements. So this is 0 and 0, 1, 2, 3, and 4. Initialize the indexes. Next, I will compare these elements, and we have to repeat the process until the pointer meet at the center. Meet at the center. So our output is here. Here nums, initializer nums, -7, 3, 2, 3, and 11. Initializer nums, and second, square the element, square the elements. Here, square array, square array, 49, 9, 4, 9, and 1, 2, 1. After the square approach, two-point approach, use two-point approach, initialize two-pointer, two-pointer, left at the starting, index 0, and other right and right index 4. First one here, left is equals to 0 and right is equals to 4. And second, compare the square of these position. Compare square these position. Square these position and place the large value. And place the large value. Place large value at the result array. At the result array. Like our result is equals to 4. Our last index here 11. So it is here square. Our output is 121 here. Right square. Right square. Move the right pointer and third move the right pointer inward. Move and the right pointer inward. Here left and 0 and our right is equals to 3. And compare again and place the large values for the next for here result 3. Here result 3. Our input nums here 7. Here we have square here 49. Next we have large values at the next point position in the result array and fill and move the left pointer inward. After that move the left pointer inward. Left pointer inwards. So our result array nums. So our result what would be here results? And so our result is here sorted. After that square element 49, 9, 9 and 1, 2, 1. And these are our the square element. Square element. Square element and these are our the nums element. Nums element. These are the our square and after that our final result we have to here sort the squared element. Sort square element. Squared element. So here 4, 9, 9, 49 and 1, 2, 1. This is our the resultant output of a sorted square array. After squaring and sorting the array that using two pointer approaches, the final result is our 499, 49 and 121. The algorithm efficiently handles the sort nature of the input array and produce the sort array. We explore a fascinating algorithmic approaches to efficiently sort the sequence of a non-decreasing order array. And n is our the length of an input array. N is noted for a input array. Input array. Both traverse the array. Both traverse the array. Let's take an implementation of a code in C++. So this is our code in C++. First of all, we have initialized the array nums int and nums.size, and we have here initialized a vector for result int. We have used here two pointer approach. So we have first one is starting the left, and another we have starting the ending point right. So initial case our left is 0, right is equals to n minus 1. N is in which here n is here for the last index of a nums array. Like our nums is 1 2 0 1 2 3 4 5. So our n 5 minus 1 means our index is 4, while left is greater than is equals to right, and left square is equals to nums left star nums left. Here we have here right square, and if left square is less than right square, so our result index minus minus a left square or left plus plus. Else we have to return here return for the result indexes minus minus right square, and here right minus minus. So we have sorted the all squares element, and we have to return here result of our outputted sorted array. It's become, let's take and run and then submit. If you find this content helpful, don't forget to like this video, subscribe for more programming insights, and hit bell icon to stay updated for our next videos. Happy coding. Thank you.